Hey there, how's it going? I hope you're well. I want to introduce to you today the Kubernetes Cron job. This is a type of resource. It went GA in version 121, I think, but it was around for a while in beta before that. And the cron job is similar to the job. So a job is used for something that you run and you expect to finish, like a batch operation will typically last perhaps seconds or maybe minutes, but probably not longer than that. And a cron job is the same, but as you can see from the clock, it's just set in advance when it's going to happen. So you may be familiar in Linux as well. It's kind of where it came from, that there is something called a cron job. And yeah, you can basically schedule an operation. So let me show you on the command line. So here we are on my usual Linux server where I've got running a lightweight Kubernetes distribution kind. So the cluster is running. In this directory I've got a single manifest called cj, which means cronjob.yaml. So let's have a look at this. And in here I've only got two resources. The first one is just a namespace for the cron job, and the second one is cron job itself. I've called it random quote logger because it's going to call on a remote API for a random quotation. It's in that namespace. This is cron notation, which you'll be familiar with from Linux. So this is set to run every minute. You can't do any more frequent than that. A minute is the minimum. And something you can set is called the concurrency policy. We've got it set to replace at the moment. What this means is if it's still running from the previous execution, then a new job will replace the old one and we won't have too many running at the same time. So there's a few different choices for this. Go look at the docs and you can find out. And then in here we also have a label. This label will allow us to look later at the logs across all of the pods that will be generated. So every minute you're going to see a new pod. That's how it's executed. And then in here we've just specified that the image is going to be Alpine. This is for our container, which we've given a name, but it doesn't really matter. And in the container, in the Alpine container, we're going to run this command. First of all, we're going to add the packages for curl and JQ. Curl because we're going to send a GET request to the remote API. JQ, we're going to need to pass the payload, the JSON object that's returned. So here we do a curl silent on zenquotes.io API random, which is the URL for the API. Strongly recommend you go check out zenquotes.io. It's a very nice test API that I use for all kinds of things. And then we got JQ, which will look for the key Q in the JSON and return the value, which is basically the quotation that we want. And in the end, we're going to echo from the container, which will obviously get written to the pod logs, quote at UTC, and here's a date timestamp, and then it will then show the quotation. And that's it. So we're ready to get started. Let's apply the manifest. Okay, apply tacf cj.yaml. And there we go, it was done. So let's have a look now. Let's do a k get, and cj is short for cron jobs. And we want to look in the namespace, obviously, cron jobs. And there you go, you can see it scheduled every minute to run. It's only 9 seconds old. Let's have a look then at the pods. I'm just going to replay that. Instead of cj, I'm going to put po for pods. Not so far, nothing. In fact, let's put a tac watch on here, and it should pop up. I guess everything is still taking its time to just happen, but it will pop up. And there you go, it's now come up. It was pending and then creating. The reason is this runs actually off the node time. It won't immediately start, but it will wait for the Kubernetes node. Whatever time is running on there, it will wait until that gets to 0 seconds before it runs this. That's what my investigation led me to discover. So you can see it's now created this container, and it ran the command that I asked it to, and of course, literally just 2 seconds later, between 3 and 5 seconds, it completed it. Now these other two entries at the end. This is some kind of, I don't know, some kind of syncing, I think, perhaps, or something like that, because on the face of it, nothing really has changed. But this will become relevant later. I will show you. I'm going to pause the video now because some more is going to happen. And there we go. This is a minute later, and you can see that a new container is going into the creating, and then the running, and then again completed in just 2 seconds. And again, there's those couple of extra entries. So kind of interesting. What I'm going to do now is I'm going to clear the screen and then run this again. We're going to wait for the third one. And there we go. Here's the third container coming through, VLHL7, and very similar again. And again, I'm not sure why, but there's always a couple more updates. But what I really want to show you now is I want to show you the fourth pod getting created, because something very interesting will happen then. So here's the fourth one coming in, TVJN7, and that's now running as well. Now, did you notice this? At the end, something looks a little bit different. There was a couple of extra ones here for the first pod that had been created, VN2T9. So if I just Control C out of this, replay the command but take away the watch, and we can just see what is there and running, then there's only 3 pods, PV, VL, and the latest one. And the original one, the oldest one, VN2T9, which updated at the end again there, it's actually, this I think was when it got deleted. It's no longer there. It's been deleted from the cluster. So this is a characteristic, let's say, of Kubernetes cron jobs, is that it will leave behind in a completed state the most recent 3 pods, but then when a new one gets completed, it will delete the old one. Now, why is that significant? Let's have a look at the pod logs. Let me clear the screen, and now let's run this command, klogs on the label. This will cover all of the pods where the pods have this label app quote logger in the namespace cron jobs, and it shows a lot of stuff here because you can see when it was installing curl and JQ. So what we'll do is we just want to see the lines for our returned output from the API. So let me clear the screen again, and this time what I'll do is I will just grep for UTC. Now then you can see here that there are 3. So 1 has come from each of those 3 pods. The significance of this is that even though we've probably already gone through maybe 6 pods by now and made 6 separate requests to the API for 6 separate random quotations, we're only ever going to see the last 3. So the point here to make is you should always consider pods to be ephemeral. You know, in this case we're limited to 3, but in any case you should not really be seeing pod logs as persistent in any way. You should always have a centralized logging solution, and in there you can store weeks, months. If you want, you can have years worth of logs, although it's probably going to use a lot of storage. You shouldn't rely on the pod logs on your cluster. Always consider them to be ephemeral, and you can lose them at any point. So I just wanted to make this point here. That's why we only have access to the most recent 3. And one other quick point to make is we have run the command like this within the manifest. You would not normally do this in real life. You would obviously have your own image and in there run whatever. You wouldn't just specify commands to be run from within a manifest. And when I say you have your own image, what I mean is you would have built your own image and not just be bootstrapping a public image in the way that we've done here. So I hope you enjoyed this video, this introduction to the Kubernetes cron job. Just go to the Kubernetes documentation. They've got a nice 1-pager on the cron job, very useful. If you like this video, please give it a like, and I will see you again soon. Take care. Bye-bye.